We've got Rudy here with us today, and we're going to be learning about how networks are evolving. Hello, Rudy.
Hi,
Thank you for being here with us today.
nice to be here.
So let's, sort of rewind a little and start with history. 20 years ago, the advent of the video hit networking like like a tidal wave. So what do you think of AI? Is the impact going to be the same? Is it going to cause as much disruption?
This is really an excellent question. And there are a lot of similarities, I should say, between what happened with video and what is now happening with AI. If you think about it, in our industry, we've been riding wave after wave of innovation for the last 2 decades. That all changed the way IP networking is being done. But none of those waves was as big as the video wave 20 years ago, because that had a profound impact on the way we're building IP networks today. If you just think about it from a capacity point of view, IP video distribution has been the main driving factor for traffic growth in IP networks now for more than 2 decades. And if you look from an architectural point of view, IP video changed the IP network as well, because it led to distributed peering, it led to CDNs being deployed in regional and metro networks. Ultimately, it led to the edge being more and more distributed, all to optimize and get a more efficient video delivery. So I think it's fair to say that video reshaped the way IP networks are being built today. Now, if you look at AI, this AI wave is just forming. I think it's very early days, but it has the potential to be as transformative to IP networks than the video wave was for a number of reasons. First of all, the expectation is that AI will also drive a significant capacity growth in IP networks. But also, as inferencing and fine-tuning capacity gets more distributed throughout our networks, what we're going to be seeing is that the networking needs are going to change. The networking needs will have to adjust to meet the requirements for that cloud connectivity in the AI era.
And how will AI impact networking?
Well, there's actually two networks involved here, or two domains involved here, I would say. First of all, there is the wide area network. That is the network between the clouds, or the network that provides cloud connectivity to the inference locations. And then there is, of course, the network within those data center fabrics itself. And both are really essential pieces of this puzzle, right? If you think about the wide area network, that is the network that is going to bring the training datasets to the training facilities. That's going to distribute trained models to inference locations, and it is going to provide the cloud connectivity for enterprises and consumers to those applications. And then if you look at the inside of those data centers, that's where you have our data center fabric solutions, both front-end and back-end networks, absolutely essential. And when you talk about AI, especially a lot of focus on the back-end networks, because they provide that connectivity bus between GPUs that is so essential.
So let's start with outside the data center first. What are your key requirements and priorities for data center
Yeah.
interconnectivity?
Well, yeah, if you look at the wide area networking and how that is changing under this AI wave, I think the key requirements are that we need to get more efficient in providing that connectivity, and security is, of course, going to be very essential as well. Now, if you look at the efficient connectivity, especially when you talk about data center interconnect, that's where coherent routing is a really important technology. We've been shipping 400 gig coherent solutions now for a very long time, widely deployed, but actually mostly in data center interconnect use cases. So the big evolution we're doing here is that now we're also introducing 800 gig ZR plus solution, 800 gig coherent routing, and that is just going to give us much more capacity in a very efficient way. The second part, of course, is security or secure transport. If you think about this AI evolution, a lot of it is pertaining confidential information, right? Enterprises are going to send their enterprise data sets to training facilities. Models are going to be trained on that information. So those models will embed a lot of that company confidential information, which will then get distributed to inference locations. So all that communication needs to be very secure. Otherwise, enterprise confidential information is going to leak out. So we're doing important things here. Encryption is key. And in this day and age, this needs to be quantum safe networking, quantum safe encryption. We're doing that at multiple layers, optical layer, data layer with MACsec and AnySec. We're doing it at wire speed in silicon. So this is a tremendous focus for us.
Let's shift gears to inside the data center now. What are your key requirements and priorities there?
Yeah, I mean, the network within the data center is, of course, an absolutely essential piece of this networking solution. And there are actually multiple networks there. There is, of course, the front end, the traditional IP or EVPN connectivity, which we're evolving as well. But for this discussion, most of the focus really needs to be on the backend fabric, that GPU connectivity bus that is absolutely essential to get to high performance training, right? And we did a lot of work, I would say, in the last 12 months, specifically to make the backend more efficient. So if you look at the requirements for backend fabrics, I would say the main thing is it needs to be scalable. We're talking here about high capacity networking, a lot of IP elephant flows you need to handle. Also needs to be automated. Automation is, of course, a key component, and it needs to be very efficient. It needs to be, or to be able to provide lossless connectivity in a very, very efficient way. And we just made tremendous progress in the last 12 months, I would say, on all these domains. If you look at from a capacity point of view, we evolved to an 800 gig optimized backend fabric now by providing all the AI capabilities, Rocky V2 transport lossless Ethernet on Tomahawk 5 and the latest IXR Generation 3 technology. So this is really fantastic. What we've also done is we did a lot of work in automating the backend fabric. This is a very complex environment. So automating the bring up the configuration, the multi-tenancy, that is important. We also added a lot of AI specific telemetry so we can give our customers visibility on the performance of these backend fabrics. And in terms of improving the performance of the backend fabrics, I think most of the work we did was optimizing and tuning the way load balancing is done by introducing flow-led hashing, by introducing Rocky V2 or RDMA aware hashing, I should say. I mean, these are important capabilities that just improve the performance dramatically.
Thank you so much, Rudy. It has been a pleasure speaking with you and learning more about the future of networking.
Right, it's great to be here. Thank you.